We're looking at this question. Find a particular solution for this second order differential equation, which is non-homogeneous. And we're using the method of undetermined coefficients. Okay. Now, undetermined coefficient is not the only method to use for second order differential equation non-homogeneous. There are other methods. But for now, we want to be focused on undetermined coefficients. Okay, so the first thing to do, the first step is to get the homogeneous equation. Get this YH. So whereby your differential equation plus y equal to 0. Then we can get the auxiliary of this equation, which is equal to what? R squared minus 2 plus 1 equal to 0. We've said that the second differential we use R squared. The first differential is the one without differential is the cos times, whereby you are writing only the attachment to that y. Okay? I mean the coefficients of that. So you can factorize this quadratic expression. This will be equal to this is 1. Factors of 1 is 1 and 1. So how do you use 1 and 1 to get minus 2? So that will be minus 1, minus 1. And when you multiply that, you get back your plus 1. So here, you now realize that your R1 is equal to R2, okay, which is equal to 1. It's a repeated root. So whereby the solution of the quadratic of the differential equation, y1 will be equal to ex, and then y2 will be equal to what? X ex. That's for the repeated roots. Okay, so then the homogeneous equation will be equal to C1 ex plus C2 x ex. So that's that equation. Then the next thing to do is to get the particular solution for the non-homogeneous part. To get the particular solution for y second differential minus 2y prime plus y equal to 5s ex. Now, this one equal to this, get the particular solution. So how do you get that? We've already explained that in our one of the videos on the rules for undetermined coefficient. I think it's one of the first video on this non-homogeneous second order differential equation. So what we do without wasting time, if you check that's number 3 of the rules, we say that if your f of x is equal to cxm erx. Okay, the first thing we need to tackle this one first. What's the m? Is it power 1? If it's power 1, that means you have a linear equation for your yp. If it's power 2, then you have what? Polynomial of what? Of degree 2. So that means if it's power 2, you're having what? Quadratic expression. This one is power 2. So we are looking at this one first. So that will be quadratic. That will be this one. You write in the quadratic form. Then you put the attachment there. Rx. Okay, that's not all. Then the next question is, want to this c is just a constant, so just a constant. Your f, your in this case now the c is what? It's 5. So you don't need that in your yp. Okay, so what we now need to note now is our root of the auxiliary equation, is any one of them equal to what? Equal to this. Equal, that is, this one is Rx. The area is 1. Is any one of these, of the root of the auxiliary equation, equal to this one, which is a 1? Okay, if one of them is equal to this, don't forget that formula we wrote like this in that note. If one of the roots is equal to r, okay, then what? This x will be equal to what? 1. But if the two roots r1, r2 is equal to this one here, okay, then it what? Your x is what? Your x is equal to 2. Is that clear now? So here now, we're having now, this will be power 2. Because the two the two roots of the auxiliary equation, they are equal to each other. And the two of them equal to what? The r here. So this is power 2, x is 2. Okay? So that's the yp. That's YP for this non-homogeneous parts. Then we can get the differentiation. Get the differentiation. We need to get the second differential, first differential, and plug everything back into this expression. And after you do that, you do the arrangement and equate the coefficients. Okay, let's get the first differential. But before that, this one times this one, that will be ax x4. This one times this one, that will be bx3. This one times this one, that will be plus cx squared equal to this. So that's my YP particular solution. Then I need to get the first differential. Will be equal to this one. This is a product rule. So I'm going to differentiate this one first. Then I have 4ax3. I'm only differentiating x4. A is constant. Then plus 3b x squared. Then plus 2c. The 2 come forward to cx. Then you keep this one constant. You keep your exponential constant. In the second part of the product rule, you now take this one constant and differentiate the exponential function, and that will be equal to what? ax4 plus bx3 plus cx squared. Differentiate your exponential, which is just that. So that's the first differential. That's the first differential. Okay. So we cannot add this one together. We cannot add because this is power 3, this is power 4. Okay. Then we get the second differential. This one, this first one is also product rule. So 3 times 4, that's 12 a squared plus 6b. 2 times 3b, that's 6b. 6bx. Then plus 2c. Plus 2c. Then keep this one constant. Then plus. Now keep your exponential constant now. Why you now differentiate this one now. Why you keep this one constant? That will be equal to what? 4a x3 plus 3b x plus 2cx. Differentiate your exponential. Then plus. Now come the second part. Differentiate this one. That will be 4ax3 plus 3b x squared plus 2cx equal to what? Ex. Then plus. Now differentiate the exponential now. Why you keep this one constant? Plus ex4 plus ex3 plus cx squared. The derivative of exponential is just the same thing because the exponent, the power is 1. The derivative of that exponent is 1. So it has no effect on that. So this is what we have now for second differential. Let's now check if one or two things are the same. Yeah, let's check. This one and this one, they are the same thing. So we can combine them together. That will be 2 pieces of that. So your second differential will now become 12 ax squared plus 6bx plus 2c. Put your ex there. Then the next thing to do, this one plus this one, and the content is the same. Let's check. Yeah. Okay. So if you add these two together, then you have 2 of that plus 2 of 4ax cubed plus 3bx plus 3bx squared plus 2cx ex. We have that for the second differential. Okay. Then plus the last one plus ax4 plus bx3 plus cx squared to bracket this. Okay. So we have reduced the 4 item of second differential to 3 items. So let's now go back here and substitute that into the given problem. So, and that will be equal to, therefore, we're now having 12ax squared plus 6bx plus 2c ex, then plus 2 into brackets 4ax cubed plus 3bx squared plus 2cx, then plus ax4 plus bx3 plus cs squared. Like this. It's a long steps. Then the first differential, minus 2, go to your first differential, minus 2. So let's start with that. So this will be times 2, times 2. The first differential will just have two parts. So we have, so that will be equal to minus 2 into brackets, first differential, 4ax cubed plus 3bx plus 2cx. Okay. Then, no, this is a plus, so that minus will also affect that. It will affect the second part. So that will also be what? Minus 2 into bracket what? ax4 plus bx3 plus cs squared ex, and then plus, what do you have here? The y. And your y is what? The y is ax4 plus bx3 plus bx3, and then plus cs squared into bracket what? Ex. So let's now check. Something we cancel out here. Something we cancel out here. Okay, and you can see from here, these two. This is two of this. This is one of these. ax4, bx3, cs squared. So we have minus 2 here. We have 1 here. So that one is combinable. We can combine that. Then what again? Let's see where we have this one. 2 of 4ax cubed, 3bx, 2cx. So this one cancel out is plus 2. This one cancel out. Okay. So then I did put equal to the right hand side, 5x squared ex. Okay. So we now have 12. We have 12 ax squared plus 6bx plus, we have 12 plus 2c, close that, ex. Then what again we have? We have here also ax4, bx3. What's happening there? Yeah, as4 is here. Yeah, bx3 is here. cs squared is here. It's also here too. So one of this, making 2. Okay, and then with this one, are they not the same? They are the same. So it cancel out. Yeah, it cancel out. Yeah, this one. Okay, as4, bf3, cs squared. So the content is the same. So this is 1 here, this is 1 here, that's 2. And check this one also, this is minus 2. So this one with this one and this one cancel out. So we only have this one remaining. Remaining. That's equal to what? 5x squared ex. 5x squared ex. So what we now do here, we can look at this. If you open this one, you have it 12a s squared ex plus 6bx ex plus 2c ex equal to 5s squared ex. So we can do the coefficient of this. Equate the coefficient of this on both sides. So we have 12a equal to what? Equal to 5. And a is what? 5 over 12. That's the coefficient of s squared ex. It equates the coefficient of I don't know what to s squared ex. equate that coefficient. Equate that coefficient. You have that. Then the coefficient of x ex, equate that coefficient also. If we equate that coefficient, we have 6b. Okay, that's the only one. We don't have it on the other side. That's equal to 0. So b is what? B is 0. Also equate the constant, the exponential terms. We don't have it on the other side. So that means 2c equal to what? Equal to 0. So c also is 0. So the yp will be equal to what? The yp is what? A is what? 5 over 12. 5 over 12. 5 over 12. 5 over 12. X4. X4. B is 0. C is 0. X4. Ex. So that's the answer to that problem. That's the answer to that problem, and that's the end of that question. It's a bit long. It's not that's the nature of the question. Also, sometimes undetermined coefficient could be cumulative. Okay, and that's why we have other methods. So if you are not told to use undetermined coefficient, you can choose another method you like. Okay, very shortly we'll go to variations of parameter to solve non-homogeneous. Okay, but if the question stipulates or you are instructed to use undetermined coefficients, you need to follow that procedure. Okay, so that's that on that. Okay, join the next video for the continuations. Okay, join the next video.